as I promised, in this video, we're gonna solve this one here. We're gonna graph this function e to minus t by hand. So this step is very crucial because we're gonna need a lot of ideas and steps to follow. The first thing that we're gonna do is, what's the domain of definition of this function? Let's call it D. D, domain of definition of our function. It's R. Why? Because every element in R, when you plug it in here, has no restriction. Okay? We don't have a problem when plugging any element in this function for any element in R. Therefore, the domain is R. Next, we're gonna find the limits. Okay, so the limit of f of t as t goes to plus infinity. So when we try to evaluate that, we see that we have plus infinity, and this is 0. So we have 0 times infinity. We can't conclude. But if we write this function as t over et, we still see that we have plus infinity over plus infinity. But this is good because we can apply L'Hopital's rule in this case. And using the derivative, we have 1 over et. And this means that the limit is 1 over et. Okay? And what's this limit here? So it's 1 over, this one goes to infinity, 1 over infinity, which is 0. Now we compute the limit of f of t as t goes to minus infinity. If we try and evaluate, okay, so here we have minus infinity times plus infinity, and which can't be a conclusion here. We can't have a conclusion, and therefore we need to do something else. Okay, try to use L'Hopital's rule here. I'm gonna use a different technique. I'm gonna change this variable here, so I'm gonna use t is minus y. And therefore I have this limit, the limit as y goes to infinity plus infinity, t is minus y. I'll take the minus outside. I'm gonna have y e to y, and this is plus infinity times plus infinity, which is plus infinity, but with the minus I'm gonna have minus infinity. Try to use L'Hopital's rule here and tell me what you think. Okay, next we're gonna see when f is positive. We note that for t bigger than 0, we have t e to minus t bigger than 0, since et is always bigger than 0. Okay? And therefore, f of t is bigger than 0 for t bigger than 0. What happens when t is 0? The statement is going to be true. Okay? Okay? So we're going to have 0 bigger or equal than 0. And therefore, f of t is greater or equal than 0 for t bigger than 0. Now, what happens when t is less than 0? t e to minus t is less than 0, because e to minus t is never 0. And therefore, f of t is less than 0. Why do we use these ones here? Why do we need this? This gonna help us because when you have the function is less than 0, it's gonna be here. It's gonna be for t. This is our t less than 0. This is our t bigger than 0. My function will be here. Will be here on the third part or quadrant. And when I have f of t is bigger than 0, my function is gonna be here in the first quadrant. Okay? So these two conditions. So here I can check if I graphed, if I found that f of t is bigger than 0 and I see my graph is here, that means something is wrong. It should not be here because of this. Okay, this will help us in graphing. Okay, next we're gonna find f prime. Okay, this is step number 4. F prime is gonna be using the product rule of derivative is gonna be t minus 1 e to minus t. or sorry, minus t plus. So it's going to be 1 minus t e to minus t because of this minus. And if I set f prime equal to 0, I have t equals 1. So t is a 1 is a point of some change. Okay, and now I can see that f prime of t is bigger than 0. Okay, when t is less than 1 because of the 1 minus t, and f prime of t is less than 1 when t is bigger than 1. Okay, what happened when t is 1, it's going to be greater or equal. Okay, so this is, so when f prime is bigger than 0, that means my function f is increasing. So that means f is increasing in here between minus infinity and 1, and it's decreasing between 1 and plus infinity. Okay, so I'm going to use that here to make a table. Okay, here I can set t. On this top row, I have the domain of definition, minus infinity plus infinity. And here I have, for t, I have this critical point, 1. Okay, and f prime is negative when t is positive when t is between minus infinity and 1, and it's negative but when t is between 1 and plus infinity. That means when f prime is positive, f is increasing. When f prime is negative, f is decreasing. And here I can get the value for 1. What's f of 1? It's 1 over e. 1 over e. I need this one when I'm graphing. And also, what's the limit? Here it's minus infinity, and here it's 0. And now here that my function is positive, that means I'm in this first quadrant. And here I'm in the third quadrant. Okay? Now I need to compute the second derivative. If I compute the second derivative, I have f prime is 1 minus t e to minus t. And f second is going to be minus e to minus t minus 1 minus t e to minus t. And once I get all that, I have e to minus t minus 1 plus t. Therefore, I have e to minus t minus 2. Okay? So this is my second derivative. I need to set it equal to 0. So here e to minus t is never 0, and the only option that would make f second 0 is that t is 2. Okay? And notice that f second of t is bigger than 0 when t is bigger than 2, and it's less than 0 when t is less than 2. That means here, when t is bigger than 2, my function is concave up, and when t is less than 2, my function is concave down. So f of 2 is an inflection point. Okay? That's why we have to compute f second, because we need to see where the function is will change its concavity. Okay? Now I think I graphed the function here separately, and I was trying to emphasize the here. So here 1, that's 1 over e, and this is the limit. Okay, note that when t is bigger than 0, my function is positive. It's on top of the x-axis. So here, this is my x-axis, this is my y-axis. Okay, and note that it's positive here on this point 2, f of 2. Look, my function is concave down when t is less than 2. It changes concavity here at this point. Okay, we don't see it clearly, but there is a change here. Okay, and it's defined everywhere, and I think this is the graph that we need. We need to have this point of inflection. We're going to come back to them. And also, f is increasing here between minus infinity and 1. It's always increasing. Here it started decreasing, but it's gonna change concavity at this point to f of t. The second question that we asked is, what's the area? What's the area between 0 and infinity of t atom minus t dt? Okay. To compute this area here, we will have to use a integration by part. Okay, and it's very simple. It's very simple. You can just use u as t and v prime as e to minus t, and doing so we'll get this area. I'm not going to compute this integral. It's very simple and it's very easy, and we have done it in a separate video in the general case, but my aim was how to graph the functions using hand drawing. Okay, and I think that's it. If you need anything or you see any errors or mistakes, please let us know. Thank you very much, and I wish you a great day.